So, Activity 4. Analysis questions. Why is binary search is faster than linear search? And when is insertion sort preferred over bubble sort? And why are brute force algorithms are not scalable? And what happens to time complexity when input size doubles? So, again, number 1, what is binary search? Faster in linear search. So, binary search is faster than linear search because it rapidly divides the search space into half instead of checking every element one by one. And linear search checks each element sequentially until the target is found. And binary search checks the middle element and eliminates half of the remaining elements each step. So the time complexity is linear search is O of n and binary search is O of log n.
So sir, now I will explain to you the codes for activity 4, which are the linear, binary, bubble sort, and insertion sort. So sir, the first sir is the linear search code. So the function starts by creating a variable called comparisons to count how many checks are made. Then it loops through the list one by one. For every element, it increases the comparison count and checks if the current value is equal to the target. If it finds the target, it returns the index and the numbers of comparisons. If it finishes the loop without finding anything, it returns a negative 1 and the total comparisons. And so next here is the binary example. So in the binary search code, the function sets two variables called left and right. This is it's to mark the start and the end of the list. It also creates a comparison counter. While the left index is less than or equal to the right index, it calculates the middle position. It checks if the middle value is equal to the target. If it is, it returns the index and comparisons. If the middle value is smaller than target, it moves the left pointer to the right side. Otherwise, it moves the right pointer to the left side. If the loop ends without finding the target, it returns negative 1.
The insertion sort versus bubble sort example code.
Now sir, we have bubble sort and insertion sort. For bubble sort, the code first starts with the length of the list. It then uses two loops. The outer loop repeats the process while the inner loop compares adjacent elements. If the left element is greater than the right element, they are swapped. This continues until the list is sorted, and then the sorted list is returned. And finally, sir, for the insertion sort, the code starts from the second element of the list. It stores the current value in a variable called key and compares it with the elements before it. While the previous elements are greater than the key, they are moved one position to the right. Once the correct position is found, the key is inserted. This process repeats for all elements until the list is fully sorted.
So what happens to time complexity when input size doubles? And if the input size doubles, so this I'll show you the complexity. First, the O of 1 or constant time, this means the time does not change even if the input gets bigger. Next is O of log n or logarithmic time. This means the time increases slowly when the input gets bigger. So O of n or linear time, this means if the input double, the time also doubles. And next is O of n squared or the quadratic time. This means if the input doubles, the time becomes 4 times bigger. And next is O of 2n or exponential time. This means the time grows super fast when input increases. So example, n is equal to 100 versus n is equal to 200. So, if you double the number from 100 to 200, linear time also doubles, but quadratic time becomes much bigger, so it grows faster. So linear search, this checks item one by one until it finds the answer. And binary search, this splits the list in half again and again to find the answer. So as stated before, and the bubble sort, this compare and swaps nearby items again and again. And insertion sort, this puts each item in its correct place by step. And brute force, this tries every possible answer until it finds the correct one. So here we can see the complexity comparison table.